So welcome to this next lesson. In this lesson, we'll be treating error analysis and significant figures. Error analysis and significant figures. So in this lesson, we will treat what errors are, and we will also see how errors are related to significant figures. So let's hop into the lesson. Error analysis is actually a critical part in scientific measures, because when we are talking about science, we are dealing with so many measurements with different units. So when we are trying to represent measurements, tendencies are that there will be levels of error. And this error can be analyzed and be reduced through error analysis. So every measurement comes with some degree of uncertainty due to limitations of the instruments or even humans. And trying to understand this error or analyze this error are significant in trying to get pure and reasonable, accurate readings. So let's go forward. Error analysis involves identifying and quantifying the error in measurement. So these errors can be systematic or random. So in the case of systematic error, they occur consistently and can be often corrected, while random errors, they can vary and they are inherent in all measurements. So there is always a random error, while systematic errors are the ones that are consistent. That is, they notice something like is repeated. You can notice it continuously. So those kind of ones that are repeated or repeated, you can look at them and be like, okay, since it seems like as if I'm trying to measure, and as I was trying to measure, I'm always noticing that there's an addition of +1. It means if I should subtract +1 from the readings anytime I use this measurement, I've cancelled out for that error. So this type of error is called systematic error. So, but in cases where the error is caused by different unknown factors, it's called a random error. So let's go deeper into these two types of errors. So these systematic errors are errors that occurs consistently and often predictable. So they are predictable and they are resulting from faulty equipment. So now I believe some of us would have tried recording, and probably maybe if you're trying to record something, you would now be hearing a bass noise, maybe something like if you want to carry out noise correction on that kind of stuff, it's easy to correct because it's a continuous repeating error. So what can be done is you just mark that particular session as a noise print and delete it throughout the entire recording. So that way it's easy to wipe all those kind of errors off. As I mentioned, in case of measurement, maybe the ruler is not really clear. You notice that the ruler always adds a 0.1 or something like that to its reading. That kind of stuff could be subtracted. So random errors, on the other hand, they vary and they are very unpredictable. So they could be caused by different reasons. It could be for air, maybe air reasons. Air could be a factor that would affect or cause random error. Human dizziness or laziness or tiredness during the measurement could be an error. Just different, anything that is not systematic is going to be a random error. So let's see. Errors, as I said, when you try to analyze errors, we then try to show this representation of errors in terms of significant figures, so that we can be able to round off errors or round down errors. So when we are trying to carry out error analysis, significant figure is one very important concept that we need to also understand. So significant figures are digits in a measurement that carry meaningful information about its precision. The number of significant figure also tries to indicate the accuracy of measurements. So when you see probably they gave you something like 0.55597, the number of significant figures in that measurement can tell you how accurate the measurement is. So if someone told you that I measured a length of cord and it gave me 1 meter, then it's either it could be 1.1 or 1.2 or 1.3 because the person was not direct. So and there's just one significant figure. So chances are that there might be an error in that measurement. But if the person told my measurement was 1.0001, you can tell automatically that okay, because of there are several significant figures in this measurement, tendencies are that this thing has a high level of accuracy. The reading is most likely accurate. So as the example we have here, I said we have 0.0045. It it's important to note something before we move forward. When we talk about significant figure talks about the first time you see a number that is not zero. The first figure that is a non-zero number. So now looking at this now, this is in two significant figure. Why? We are seeing 0, 0, 0, 0, 0 here. But because 0 came before the first normal number that is not 0, you would ignore those zeros that came before it and start from the first real number. So if it's 0 between, let's assume we have the same number, 0.00405. The significant figures here are three significant figures because we have 4, 0, and 5 in this digit, because when you have the zeros coming before the first number that is not 0, you would take them as irrelevant. But when it's after or in between, those zeros are relevant. But if it's after, in the in case of decimal, let's assume we have something like this now, 0.75000. These zeros are insignificant. This 0 is insignificant. These two are the only significant figure. So you can say this is in two significant figure. If we had 0.102500, the first significant figure here is 1. Next is 0. Next is 2. Next is 5. These other ones after, because they are after the decimal point, they are seen as negligible. So significant figure always starts from the first number. So as we have something like 10.345. The significant figures are this: 1, 2, 3, 4, 5. So those are the significant figures that we have. So it's a 5 significant figure system. So let's move forward. Let's move forward into this lesson. So now, when we talk about significant figure, you could either round off significant figure or round down significant figure. So the basics for rounding off and rounding down is what I call the 5 rule. The 5 rule. So this 5 rule, what it takes is that when you are trying to round off numbers to a particular significant figure, say let's assume we are trying to round off 0.5678. We're trying to round it off to 3 significant or to 2 significant figures. You check where is the first significant figure. The first significant figure is 5. Next is 2. Next is 3. Next is this. So we are rounding up to 2 significant figures. So meaning you count the first and second significant figure. So the next number that is following it immediately, you check if it's up to 5. If it is up to 5, you add 1 to this here, to the number that is before it, or the last significant figure that we are being asked to check for. You add 1 to it. But if it is less than 5, you would not add anything. So assuming we add something like 0.5607. We're trying to round to 2 significant figures. These are the first 2 significant figures. So this one now is not even up to 5. So we call that the final answer will be equal to 0.56. So but in cases where you have probably 0.5657, this is the first significant, second significant, the asking us for 2 significant. So the third number after the first 2 significant number, you would check if it's up to 5. So since it's up to 5, you would then add 1 to this, so you'll be having 0.57. So that's how we check for rounding off and rounding down. So moving on, we have that there are importance of significant figures. So significant figures are very essential for maintaining the accuracy and precision of measurements. So they try to help to convey the reliability of data, and also try to ensure that results of reported readings are accurately measured. So significant figures are used to increase level of accuracy. So as I said before, you just told me, I think I spent 1 hour at the gym today. I cannot tell if it's exactly 1 hour, but the more significant figures you give me, when you say I spent 1 hour 39 minutes, the more accurate I am to predict when exactly you left the gym. So that's how significant figures work. They can help to improve accuracy. So in conclusion, this session we've tried to discuss error analysis, and we've also tried to discuss the different types of errors. So that will be all for this lesson, and I'll be saying goodbye.